today's presentation with Freemelt. With us presenting today, we have the CEO, Daniel Gidlund, CFO, Martin Granlund, and Regional Manager, EMEA, Victor Valk presenting. If you have any questions, please use the form located to the right, and we'll take that up during the Q&A. And with that said, please go ahead with your presentation.
Thank you. Okay, today's agenda is mainly about our Q4 result but also the closure of 2024. And as we always add a specific topic during these webcasts to zoom in on, today we have actually added two. It's defense and also then region EMEA. So please raise any questions through the chat during the presentation, and we'll try to answer them during the end of the webcast as well. So welcome to all. This information may be a bit of a repetition for some of you, but as we gladly have thousands of new shareholders since the beginning of 2025, I want to just make a brief, let's say, recap on who we are, but also what we do. So at Freemelt, we develop metal 3D printers, and of course we try to develop and work within areas where additive manufacturing adds value. So when it comes to the Freemelt technology, this is really in areas where the demand of high complex and high performance materials and applications are needed. And this is typically seen like in defense, in energy, and also in medtech. Our technology, it's not really, let's say, limited to any kind of materials, but also here we have tried to focus on materials that really make sense and add value for those applications. So we mainly work with tungsten. Tungsten can be used pretty much in all three of the applications: defense, energy, and medtech. We work with titanium, which is mainly within medtech for orthopedic implants, and then copper, which actually can be used both in energy and defense. How Freemelt differentiates within 3D printing? I mean, 3D printing has been pretty much up for 40 years. It's a lot of different kinds of suppliers. We are in something called an electron beam powder bed fusion, which represents roughly 10% of powder bed fusion manufacturing. The remaining 90% is laser. But we have a unique system to any other system in the market. We have modular printers, and the main reason for this is really to reduce the cycle times in production. So really get up productivity, which means that you can reduce your cost per parts manufacturing, which is absolutely critical when you talk about serial production. Our go-to-market is both through the academia side, and the reason for this is that it's still a lot to educate the market about the values of additive manufacturing. And here we try to first use the universities and research institutes to develop new material processes, but also new applications for the industry, but also to bring PhD students that's been at the universities that really been taught about additive manufacturing and Freemelt technology. And when they then go out to the industry, they keep this in mind and bring that value to the industry. And then the other segment that we work directly with from, I would say, last year is the industrial side as well. And here a few of the agreements that we made last year is with Saab Dynamics in defense. And then we also had two major achievements end of last year, which is in the orthopedic implant side. We had three different kind of offerings of machines, as you can see on the left side. One open source research machine called Freemelt 1, and then eMelt is our industrial concept for serial production. Despite that we only, let's say we are in the 8th year now, we are number 2 in the world in this specific segment after GE, which is number 1. And we have so far sold 31 machines. If we then quickly look into those industries that we mainly invest our time and engagement with customers, the first one is defense. And I think I don't need to dwell too much about the focus that is in defense at the moment. I mean, I think actually these numbers that you see on the slide here must be revisited. I think the most probably the growth will be even higher, especially if you look into Europe, that just recently made a decision to ramp up the investment in defense substantially in Europe. We are exposed, as you can see here as well, to different kind of defense companies. You know, as we are a public company, I can only, of course, share what we have shared publicly. But these are a few that at least has been okay to share in names. So it's both with research institutes working with defense industry, and as you can see, some industrial names as well. If we go then to energy, same kind of thing here as well. I mean, really, because of the geopolitical situation we are facing now, energy and let's say to become more independent on energy sources has been really ramping up the increase of focus here as well. One of the areas that we are heavily exposed to, and I would say that we have an extremely good position, is in fusion energy. And here you can also see a couple of names and companies and institutes that we are working together with when it comes to fusion. And UKAEA is someone that we have been working on for pretty much a year and a half in different kind of projects, but also now we sold an industrial machine to as well. And then last and definitely not least, medtech. And this is mainly when it comes to orthopedic implants. This is the industry so far with the highest adoption to serial production with additive manufacturing. Having that said, only 5% of the world's orthopedic implants are produced through additive manufacturing. The industry claims that it will be more than 20% by 2032. So it's a huge increase expected from an AM perspective in the medtech side as well in the next couple of years. Let's then zoom in on our first focus here in this webcast, so defense. And again, where we have seen a huge increase in interest only during, I would say, the past 12 months as well. And I personally must say that, you know, during my 2.5 years at Freemelt, I've never seen an application now where AM can bring such a high value as well as it can for defense. And I will try to explain how as well. So first of all, when you hear the name additive manufacturing, I mean, this is a process where you add powder layer by layer. And the powder, just to give you an understanding, I mean, the powder is a size like a strand of hair, and which then you melt layer by layer. So Freemelt, we have an electron beam technology, as I said, and one of the key benefits here is speed. So what you see on the upper right side here, the green dots, you might think that it's a lot of lasers that are pointing, but actually this is one electron beam moving 4 kilometers per second, so extremely fast. So it actually melts roughly 3,000 spots per second. And what we also have, we have a high temperature process, which makes the material properties become the best. And it's also in vacuum. So this makes it possible to actually manufacturing parts in new type of materials and get the highest material properties, which actually is not possible with traditional manufacturing technology like casting. And if you take tungsten now, that is in such a focus, especially in defense and energy, here, which has the highest melting point, it's actually not possible to cast because the mold will actually melt them. So here, additive manufacturing really brings a different level of value as well. But let's then come back to defense. So, I mean, as all of you know, I mean, defense is highly sensitive application, and this is where, especially in this geopolitical situation now, you really want to be in control of the entire process. from the material to the final part. And if we go, back, a few years when we didn't have this geopolitical situation, actually a lot of the components, even in defense, were actually manufactured abroad. So you had outsourced that manufacturing. And this is why now defense industry really quickly wants to take back the full control and manufacture all parts locally where the part will be used or needed. And the good thing here with a 3D printer is that it's a digital process. You can even place it in the battlefield as well, if that's where the parts are needed. The other great value with additive manufacturing is that this is, as I said, a fully digital process. So this means that you don't have any kind of design limitations, which means that you can design and you can manufacture the end functional part in one process. And I mean, the time to market to really ramp up volumes quickly, which is also extremely important now. And as I said before, Europe is now quickly trying to ramp up volumes. And this is really where additive manufacturing can add another level of value as well. So in a really efficient time, first develop the prototype and then ramp up in serial production. It's definitely something that where AM brings a huge value to the process. And I think also, I mean, all of us have seen that, for instance, if you take the ongoing war now in Ukraine, then it's also a new type of weapons that are being used, such as drones, hypersonic missiles, for instance. And some of these applications require really high material quality to manage the extreme temperatures that are generated in, for instance, high speeds, for instance. And this is where materials like tungsten have been a very, a very high demand and interest recently. And as I said before, here at Freemelt, we have a very strong position in how to manufacturing tungsten with full density and crack free as well. So I hope this gives you a better understanding of the value that AM and Freemelt technology brings to the defense industry. And on the next slide here, I think you can see a few more examples. This is from one of the big defense US defense companies. They bring up, for instance, when it comes to creating new parts, again, it's a digital process, and the time, as I said, from prototyping to serial production, it's pretty much seamless, which then reduces the time, but also the cost for the client. But you can also improve all parts. And I think here, if you zoom in on the middle part of the slide, again, tungsten. So by using new materials then, such as tungsten in this case, and printing tungsten. So in some cases, you can actually you can manufacture tungsten by high pressure, but then you cannot get the full density and the crack free part, which means that you don't get the properties you can get with additive manufacturing. And then lastly, one of the greatest benefits with AM is that you can build the functional part in one process. So instead of like traditional manufacturing where you manufacture different parts and then you weld them together to get the functional part, here you can do it in one process. So again, from prototype to serial production, much more efficient, but also the product becomes much more stronger as well than having different kind of welding points. So with that said, I would like to hand over to Victor.
Thank you, Daniel. So thanks for having me here. I started with Freemelt just over a year ago, last year, February. And prior to that, I've been with another Swedish company, Sandvik, for about 10 years, where I had different positions in their mining and rock technology business. So over the last year, I've been mostly focusing on getting a structured approach in sales for the EMEA region to generate volume of both prospects and leads. And I believe that currently we're starting to see the effects of that, where we have a really good-looking, solid sales funnel for the coming quarters, both at the end of the sales funnel, but also still at the start where we're filling them up. We're seeing good engagement both within industry as with research. So with industry, we have engagement with all of the focus industries like implants, defense, and energy. I will actually get back to that in the next slide, but with defense next week, we'll be at the European Additive Manufacturing Military Symposium, where you basically get people from industry as different defense organizations across Europe who focus mostly on additive manufacturing. So it'll be a really good opportunity to meet the industry. And we had great progress as well with energy last quarters with both studies and feasibility and actual machine sales to UKAEA. At the same time, we have a lot of activities ongoing in research. So we are working on several tenders to actually get more machines out there to that part of the business. So one of the things we do is we keep track of how our industrial customers are proceeding towards industrialization. And we have identified different steps towards industrialization, where we start at material qualification studies, then application testing, prototype printing, and from there actually checking production scalability before we see it actually being ramped up in the industrial use. And over the last months, we have also seen a lot of progress of our customer base moving from initial material qualification studies closer to production scalability testing. So with UKAEA, a couple of years ago, we started with a material qualification of tungsten for fusion energy plants. And last year, we started the second study with them. And this year, in the first quarter, we got an order for a qualification study with them to actually check production scalability and also qualify the parts to be used in the new energy plant. At the same time, we've seen that they also have decided to invest in a machine themselves so that they can continue to do this in-house with our support. Also, we see that new companies are coming in when it comes to fusion energy. So we started with material qualification, the first study together with Oxford Sigma, another company from the UK. Last year, we also successfully finalized a material qualification study with Saab. And this year we started working on an application testing study with them as well, which we will also conclude during the first half of this year. We also have good traction with the implant industry, which Daniel already mentioned. They are most ahead when it comes to industrial use of 3D printing. So we have two projects ongoing with two major OEMs of implants, and we are continuing to work with them, and we expect to see the first results during this year. As we proceed, we'll continue to track the different studies that we start, and also see how they move up in this path from material qualification all the way to industrialization. Just to highlight, there's only a couple of companies listed here, but last year, since the start of 2024 in EMEA, we have started with 23 of these studies in all different industries that we work with. So I think I would like to pass the floor now to Martin, Daniel.
Thanks, Victor.
Thank you, Victor. Thank you, Daniel. So turning to some of the figures from the last quarter and the past year, we already released some preliminary figures on January 27th. So some of these were not new to the audience, but I'd like to highlight on the left side the net sales. So 8.2 million in Q4, which is not dramatic in itself, but the mix is interesting. So the light green area is revenue from machine sales. In Q3, we booked 2 machines. In Q4, we booked 1 machine, but it's 66% of revenue. And what we see growing is the project part. So that's the gray part. Project revenue from projects is growing, and that reflects what Daniel and Victor have been talking about, that it's not a large part of our revenues, but it is increasing, and it's paid projects which we hope to convert to machine sales at some point in the future. Similarly interesting is the dark green part, which is aftermarket. So our ambition is to grow aftermarket up to the year 2030, and we are seeing an increased proportion of sales coming from aftermarket as the install base increases over time. On the right-hand side is the order book. So at end of Q4 2024, we had 12.4 million SEK in the order book. And the order book is defined as purchase orders received, which we haven't yet invoiced. So it's not in our official books anywhere. This is a slight increase from the third quarter and a very large increase from the same period last year, or 2023. And the big part of what drives sales is machine sales. So that's, of course, where the big money is, and that's driving this figure. Cash flow. On the left-hand side, you see the operating cash flow being visualized. There is an improvement in the last quarter compared to Q3. It's still negative, 8.9 million in the last quarter of last year. And this is mainly driven by the negative result, but also from inventory buildup, which is ahead of anticipated machine sales in the beginning of this year, as you've also seen. I would also like to highlight the rights issue as a final point. So in the first quarter, we successfully finalized a rights issue, providing the company with 90 million SEK before costs associated with the rights issue. And this will take us a long way further for the industrialization and commercialization of our products. What's also important to note is that there is a warrant called TO1, which is part of this capital raise, but it goes into effect, or it expires in June 2026. And I think this is also something to keep track of, not only the Freemelt share, but also the warrants and the structure of the warrants, which is quite attractive for shareholders. So it expires in June. The price of the warrant is going to be set in May, and it's going to be a rebate based compared to the price set in June, so 70% of the price. And there's a cap on this price, which is 1.33 krona per share. So I would like you all to just keep track of this one as well, and not only the Freemelt share. This warrant also brings proceeds to the company, depending on the subscription rate, but up to slightly over 50 million SEK. Thank you.
Thank you, Martin and Victor. So then let's wrap up Q4 and 2024. I think Q4 represented 2024 as such, by having 7 new paid customer projects, and where the highlight were actually 2 strategic agreements with 2 of our global implant OEMs, as Victor also mentioned before. And I think, first of all, I mean, as we said, the medtech industry has the highest adoption, the highest experience, and also the fact that they are giving Freemelt the trust. I think it also it's really pleasing to see. It's also really pleasing to see as well that all 3 industrial focusers are showing high interest and demand in our technology, and where we so far since then, when we launched the industrial offering mid last year, have sold 4 eMELT machines until now. And customer references are absolutely critical for Freemelt now to accelerate our market penetration forward. I think it's also very promising to see that in all our industrial focus areas, and especially I would say in defense and energy, both of them are really under substantial transformations at the moment. And as I tried to explain, at least for defense, but it's the same for energy as well, additive manufacturing or innovative manufacturing or advanced manufacturing, whatever you would like to call it, will play a critical role, both regarding the innovation of new type of materials, new type of parts, but also, again, the local manufacturing, that they can get full control of the manufacturing or the supply process of this as well, due to the geopolitical situation that we are facing. I also want to take the opportunity to thank all our shareholders for the trust and support. I mean, Freemelt, we are now entering its 8th year, and with a machine offering now both for research and also our industrial customers, our key focus is to scale up now for growth with a clear path towards profitability. So lastly, I'm not sure if you follow Freemelt on LinkedIn. I did wrote in my year of end summary at LinkedIn that most of the time you overestimate technology in the short term, but you underestimate it in the long term. And I think now we are at the time where 3D printing or additive manufacturing is really gaining momentum, driven by structural long-term trends in defense, energy, but also in medtech. So with that said, thanks for everyone's attention today, and let's open up for some questions.
Thank you very much, Daniel, Martin, and Victor for that presentation. And let's dive into the Q&A section here. We'll start with the first one. In the Q4 report, you mentioned starting 28 new paid customers project during 2024, compared to just 3 in 2023, which is an impressive increase. What would you say are the key factors behind this success?
Yes, good question. Yeah, I think, first of all, I think as a company, we are getting more and more mature as a commercial company, but also from the technology such as well. I would say that this is a part of our commercial journey that we sort of started end of 2023, but really trying to accelerate during 2024, where we have had a structured and also a persistent approach to increase the brand awareness about the Freemelt. As I've mentioned before, it's a lot about educating the market about the opportunities with AM, but also to educate about Freemelt's technology. So I think now when we have 2 commercial teams, one in EMEA and one in the US, I think it just proves the great work they have been doing. But I think also, the technology as such, Freemelt technology, being more present at universities and research institutes, it has also increased the interest of our technology. But lastly, of course, the geopolitical situation that has really turned from having a bit of a headwind, trying to again educate and try to really push for the interest of AM. I think now we start to get tailwind, and now the demand is really coming from the industry, and I think that also is one of the key reasons why customers now prepare to pay for trying out the technology as such.
Thank you, Daniel, for that answer. And during Q4, you also strengthened your collaboration with Saab Dynamics for defense applications. Have you also noticed a growing interest in innovative technologies like additive manufacturing due to the increased geopolitical instability?
I think maybe Victor, you can.
Yeah, I can take this. So I think within defense, we've always seen a strong interest in additive manufacturing over time. And I think it's also quite well adopted in some of these applications. But I think there is definitely a big increase in interest coming from defense, also coming from due to the geopolitical instability. And a lot of that can be explained also by what Daniel already explained, is that first of all, AM has specific capabilities to make parts, to make whole assemblies. So you're not, you don't have to weld things in the field or those kind of things. So you can make everything at once. But also it helps a lot to shorten the introduction time of new products, because you can test, you have a lot of possibilities to use the technology to do experiments. Especially, of course, our open source technology facilitates this. And then we also see that there's a shortened supply chain if you use AM, and we can also have a local supply chain, which because of geopolitical instability becomes more and more important. So yeah, this is definitely giving us some tailwind, as Daniel described it just now.
Thank you, Victor, for that answer. You just informed the market that you have received a new order for the industrial machine emailed from UKAEA. Can you tell us why this is a strategically important business?
I think I can take this one as well. We've been working with UKAEA quite some time already, and we've been working with Fusion also quite some time, and we've seen that we've had several orders from Fusion. And the Fusion energy market, even though it's still very experimental, is definitely expanding. And we see that there's a lot of investments coming within this market and energy as such, and we expect that there will be an increase of around, from today, 300 billion euros of investment to 500 billion of investment by 2030. And even though it will take time before we can see fusion energy being adopted to an energy source that is used for all of us to be used at home, there will be still a lot of prototype plants that need to be built, and they require millions of tiles that we can manufacture with our machines. So even if you look at the prototypes that they will be building in the UK or in France, we would need several machines to actually manufacture all the tiles that are required. So it's a very good market for us from that perspective. And we're also very well positioned, as we've been working together with UK for quite some time. And now we're also working with more companies within this sector too.
Thank you, Victor, for that answer. And we'll take one final question here. Now that it's a busy time for rearmament, could this mean shorter or even faster lead times to reach proof of concept?
Yes, I can take it. Yeah, absolutely. I think because you have design freedom within additive manufacturing, you can do a lot of designs that you can test very quickly. And we can also see, I think this is for Saab interesting as well, that we can make something and they can trial it quite quickly. So we will definitely see a shorter time of new product development, new product introductions due to our technology or due to AM as such. And this is something that will also help with the rearmament of Europe, as you say it, and also rearmament of new technologies.
Okay. Thank you very much for all of your questions, Daniel, Martin, and Victor. And that's a wrap of this conference call with Freemelt. And I wish you all a great rest of the day. Thank you very much.
Thank you.
Thank you all.
Thank you. Bye-bye.
Bye.